It's my distinct pleasure to introduce Dr. Rodney Howell. I will only say of his accolades that he currently is Professor Emeritus at University of Miami, was the first chair of the Secretary's Advisory on Heritable Diseases, but more than that has been, I think in many people's eyes, the father of, or at least godfather of newborn screening as it exists today. And he's also been a personal inspiration to me. I got into genomics at mid-career, not in early career like so many of you did. And I sought his counsel and sought his advice and have continued to do so through the years. And through that, I heard some of the reflections that I hope he'll share with you tonight. And I just think he's an amazing leader, an amazing human being, and still contributing over an extraordinary span of decades. So Dr. Howell, I would love to welcome you here and thank you so much for coming up. That's good.
Robert, thank you very much for those kind remarks. I'm going to speak to you tonight quite informally and without slides. I think the first time I've spoken without slides in at least 50 years. So that will be a new experience and so forth. But I'm going to interject a variety of personal things throughout this because one of the great advantages of being around for a long time is the fact that I've had an opportunity of being at the very beginning of newborn screening, and I'm still here today. And so I'd like to reflect on some of those issues. The other thing is that my remarks will be quite informal, and I will look forward to hearing your comments. I've written these down so that I will not keep you until next Monday night, so that we will try to stay on schedule. Newborn screening developed out of necessity after the discovery of a treatment which had to begin in the newborn period for a disastrous disease before symptoms developed. Phenylketonuria was the original condition that demanded newborn screening. The discovery of phenylketonuria began with an observant, very bright, persistent mother. It was the late 1920s in Oslo, Norway, where a young couple, Bjorni and Harry Egeland, had started their family with a bright young daughter who over time lost all of her milestones, and by age 3 years, she could not say a single word. Their second baby, a boy named Dag, although very bright at birth and very exciting at birth and so forth, deteriorated really quickly. And at 4, he could not speak a single word. The Egelands had noted a very strong odor coming from both children, and Harry, who had asthma, was said to have difficulty in staying in the room with the children because of the strong odor that came from them. Harry was a dental student at that time in Oslo, and he became aware of a professor at Oslo named Asbjørn Furling, who had studied metabolism and physiology in Colorado and was particularly interested in acidosis. In 1934, Dr. Furling agreed to see the Egelands, thinking he probably couldn't do anything to help them. He asked, however, that the mother bring urine from the children to his makeshift laboratory, where he tested the urine with ferric chloride, which was widely used at that time to test for acetoacetic acid, which was of interest to him in his studies on acidosis. The presence of excessive amounts of ketone in urines when ferric chloride is added generates a dark, characteristic purple color. But when ferric chloride was added to the urine of the Egeland's children, a deep, evanescent green color developed. He had never seen that color before, and it was not reported in the literature. Furling began isolating that compound by very laborious precipitations, and some of those that have been old timers in the lab understand how precipitations are done to precipitate other stuff and so forth. But anyway, he was able to follow the presence of this compound because of its green color, so he could test the precipitate, and if it was green, he knew he had the compound. And he identified this compound after 2 months and 22 liters of urine. He isolated and characterized that compound as phenylpruvic acid, which is a metabolite of phenylalanine. In order to confirm that phenylpyruvic acid was related to their delay, he tested other children in and around the institutions for the developmentally handicapped in Oslo. And he found a small number, albeit a small number, of children and adults in these institutions who were profoundly retarded and who had the same green color. He published his research in 1934. I might point out, for those of you who are in the audience who write a lot, he started his work at the beginning of 94 and it was published in 94. And he published it under the name of phenylpyruvic oligophrenia. If the elevated phenylalanine and its metabolites were at fault with the delay, it was felt that the condition might be treated with the restriction of phenylalanine, an essential amino acid. However, there were those who felt that the delay and the elevated phenylalanine were unrelated issues. At that time, World War II was raging across Europe, as you well know, which slowed research. Another key issue was it was not clear how one would prepare a diet that was solely deficient in phenylalanine for a clinical trial. After World War II, Horst Bickel, a German scientist, was on a fellowship at Birmingham Children's Hospital in the UK, and he was aware of the work of Professor Louis Wolff, who at that time was at Great Ormond Street in London, and who was working on special diets using casein hydrolysase. Professor Wolff was also aware of other scientific work that had showed how to remove aromatic amino acids with activated charcoal from these casein hydrolysase, because he was working with World War II victims on starvation. With the help of Dr. Wolff, Bickel prepared a special diet deficient only in phenylalanine and treated a young girl named Sheila at Birmingham Children's Hospital. She improved quite strikingly on the diet. They placed her back on a regular diet after she had improved on the special diet, and she deteriorated. And so they concluded clearly that the phenylalanine was a harmful product. But on the other hand, they concluded also that you probably needed to start the diet early in life to be maximally beneficial. So to accomplish this, you would need an inexpensive test suitable for testing the entire population before symptoms of phenylketonuria developed, in other words, to diagnose and treat the babies early. Meanwhile, back in Buffalo, New York, Dr. Robert Guthrie was working on nutritional products that were related to his cancer research. He was the father of a child with developmental delay, and therefore he was known to the families in that particular community. He was approached by these families with the problem of measuring phenylalanine simply, inexpensively, and widely, and he developed the use of the dried blood spots, which he placed on agar gels in which B. subtilis spores were embedded. The size of the growth zone around the dried blood spots on the gel could be related then to the phenylalanine content of the dried blood spot. This was an effective and semi-quantitative way of measuring phenylalanine cheaply and certainly inexpensively. Also at that time, in the United States, the diet low in phenylalanine was commercially produced quite rapidly, and pilot studies around the country were identified, and it was clear that great benefit from this diet starting early was essential. I just left the National Institutes of Health at this time, the intramural program, to assume faculty positions at Johns Hopkins Hospital, where I cared for these children. The children were just being treated for PKU, and we were working with the state of Maryland laboratory, which was testing for phenylalanine. I will really never forget the tragedy of seeing a young teenager that came to my clinic with untreated phenylketonuria. His name was Mike. He was just short of 6 feet tall. He was blonde, blue-eyed, didn't match his family, his Italian-American family at all in color. He had no speech. He was 16 years old at that time. He was not toilet trained. And he had obviously extraordinarily profound delay. I mean, unimaginable delay. Bob Guthrie visited our hospital and discussed his new simple test, and I must admit, I thought the system was far too simple to work well, but it did work, and it was quite effective in the newborn screening program. There were issues with the diet. Let me be clear about that. At times there was weight loss, there might be anemia and so forth. And the diet, however, needed to be very closely monitored so you didn't get into irreversible complications. The possibility of identifying and preventing developmental delay was truly electrifying at that time in the professional community. Developmental delay had long been considered totally untreatable. Quickly, virtually every state in the country began screening for phenylketonuria in some form or another. President Kennedy hosted Professor Furling in the White House and some other scholars there, and presented Furling an award from the Joseph P. Kennedy Jr. Foundation for his excellent work in discovering this compound. Since this was such an important discovery, the newborn screening programs were placed in the public health sector, assuring that every baby in the United States would be tested and treated. And still today, all newborn screening programs in the United States are assigned to the individual states. A major leader in the development of newborn screening was Dr. Harvey Levy of Boston Children's Hospital right here, who remains a leader today. Harvey, with the state laboratory, oversaw the institution of screening for phenylketonuria in Massachusetts, which is the first. After the mandatory screening for PKU in Massachusetts in 1963, rapidly states began screening for PKU, and by 1966, PKU screening was mandatory in most states. As screening conditions continued, the states continued to add more conditions to the panel. The decisions of what to add to the panels varied enormously, both in the decisions of what to screen for and how that decision was made. In the 1990s, Dr. Donald Chase, David Millington, and colleagues introduced tandem mass spectrometry to the newborn screening program, an enormous advance that permits accurate screening for large panels that we screen for today. The variation between what the states were screening for became even greater, which was recognized to be a very big problem for our mobile society with variations from state to state. There was no uniform approach to your screen conditions. I might comment briefly about, I was at the discussion later today and heard a number of people discussing who were new to PKU, some of their ideas and so forth. And I might point out virtually everything I say, I could spend a week talking about because there are exceptions, there are complications, and I'm just hitting the high points. So let me just point that out. In 2002, the Health Resources and Services Administration addressed these problems by issuing a contract to the American College of Medical Genetics and Genomics. This was a broad contract, but the core issue was to convene experts in all issues in which newborn screening had been done. Based on updated Wilson and Younger criteria for newborn screening, this ACMG expert panel concluded that what should be on a recommended panel. After extensive work and meetings that lasted over 2 years, this expert panel recommended that all babies be tested for 29 individual diseases. During this same period, the Children's Health Act of 2000 had passed the United States Congress. Things were different in that days. Things passed Congress and so forth, and it was signed by the president. And it recommended the establishment of the Advisory Committee on Hereditary Diseases of Newborns and Children. And although this committee had and has a broad charge, its central goal was to deal with newborn screening issues. The committee held its first meeting in 2003. The committee had a broad representation of membership with experts, included many from the federal partners. I had the honor of serving as chair of this committee for its inaugural 8 years. The committee spent 2004 and 2005 studying the ACMG report in great detail. After this, the Federal Advisory Committee recommended that all infants be tested for these 29 conditions. The deliberations that went into this recommendation was enormous because making recommendations of this nature about very rare disorders is very complex, since one can't do standardized tests that we're used to doing in clinical medicine. The New York Times in 2005 covered this report with an extensive article by Gina Colada. Gina Colada clearly was one of the New York Times' very best writers. It is the only time that I've ever seen newborn screening on the front page of the New York Times, perhaps the last time. But anyway, the report generated considerable controversy. Persons with divergent views were interviewed by the Times, and although the advisory committee had included an array of experts, including families and persons who had benefited from newborn screening, perhaps the most remarkable comment in the Times article was from one professor of ethics, who was quoted as saying, and I quote, "The majority of newborn screening tests have failed." And he further continued, and quote, "Thousands of normal kids have been killed or gotten brain damage by screening tests and treatments that turned out to be ineffective and very dangerous." That's an exact quote from the article. That certainly was not the case in organized newborn screening, nor has it been supported in the subsequent years by published studies. The conditions recommended by the Federal Advisory Panel Committee was called the Recommended Uniform Panel, or the RUSP, by which it is known today. The current newborn screening programs continue to benefit children greatly. Through early detection, at least 12,500 babies in the United States receive life-saving or life-altering treatments and interventions annually. When thinking about the long-term benefits of phenylketonuria treatment, I'm reminded of a friend of mine that I've known for many years, who was born just under 50 years ago in Cleveland. And he was screened in the newborn period, put on a low phenylalanine diet, which he has adhered to until today. He was a good student in school. He graduated Alpha Omega Alpha from a medical school in Philadelphia. He has also a DDS, and he is a very successful and productive oral and facial surgeon. And so it's unbelievably exciting to see him. And of course, were he in the room, he would not be distinguishable from any of you, and so forth. But he's very bright, articulate, and more importantly, rather than being a tremendous drain on society, he has been a very productive member of society all these years. The newborn screening community involves all of our states, as I've mentioned, in this country, commonly through their state laboratories who perform the test. In addition, there are obviously several commercial laboratories that contract with various states to help with the newborn screening program. There are large numbers of physicians, scientists in nutrition, and others in the rare disease community, commonly located in our medical schools throughout the country, who devote their research and careers and clinical careers to rare diseases. The newborn screening community is regularly looking to identify issues to enhance our current newborn screening program. And there are many issues that come up, but some of the prominent ones under current discussion are mechanisms by which the Secretary's Advisory Committee can more rapidly review conditions for the Recommended Uniform Panel, while at the same time continuing the rigor of these reviews and decisions. This is particularly important, as you all know, since there are rapidly increasing numbers of rare diseases for which treatments are being approved by the FDA, and which treatments must be started in the newborn period for maximum effectiveness. Also, a key issue that is a very substantial issue is to identify better funding and to enhance the staff of the state laboratories for the current and expanding number of conditions that the laboratories are asked to take care of. And on the horizon, a key issue of this conference is a considerable group of rare and at times very rare conditions which will require genomic sequencing as a primary diagnostic technology. Although there are a number of conditions in this area, including several leukodystrophies, I would like to comment at this point about a very rare condition we have known about for a very long time. This condition without treatment is eventually fatal due to kidney failure, has been widely studied for decades. even by me in the old days, and for some, for which we now have a very effective treatment, which must be started in infancy. This condition is nephropathic cystinosis. Nephropathic cystinosis is a rare autosomal recessive lysosomal storage disease. Although cysteine is deposited throughout in all the cells of the body, it initially causes loss of proximal glomerular function, tubular function with the Fanconi syndrome, and a progressive loss of glomerular function, and finally with end-stage renal disease at approximately 10 years of age. Cysteine deposits in the cornea of these children, these young children, lead to a characteristic photophobia. They always come to the clinic wearing dark glasses because of the sunlight and the crystals in their cornea that cause that. The mutations affect a protein, cystinosin, that transports cysteine out of the lysosome. One can measure elevated cysteine content in many tissues, including leukocytes, but until now, there has not been any method of testing this in the newborn period. Now, there is a very effective clinical treatment using a small molecule free thiol, cysteamine, which depletes cysteine, the cells of cysteine, and has salutary effects on renal function, growth, and non-renal complications. However, at the current mean age of diagnosis at 14 months, severe damage has already occurred by the time you're alerted that cysteamine is required of the physician. The long-term study of cystinosis and its downhill course, along with the clear demonstration that cysteamine is very effective in treating these children, and now that we know the pathogenic variants that have been identified in cystinosin from patients with cystinosis, make it a very good candidate for newborn screening. Recent studies of newborn screening for cystinosis in Germany has established a program that incorporates high-throughput first-tier molecular genetic testing for cystinosis. Recent studies of 6 patients diagnosed before 2 months of age and treated early with cysteamine. 5 of these patients were diagnosed because of family history, but 1 of the patients was diagnosed by newborn screening. And now 4 of these patients are ages 2, 4, 10, and 16 years of age, and have been treated since early infancy with cysteamine. And these infants treated from birth can avoid kidney replacement therapy of all kinds. The benefits have really been quite dramatic. The case of cystinosis and certain other diseases clearly require careful study of how to integrate genomic sequencing into the newborn screening program. Although genomic studies are already in use in the state laboratories for important conditions such as spinal muscular atrophy and as a secondary test for cystinosis, for cystic fibrosis. Pilot screening studies are underway for Duchenne muscular dystrophy, and a couple of the people in this room are heavily involved in those studies, using creatine kinase as the primary test. Infants with elevated screening creatine kinase levels will immediately need genomic testing to confirm the diagnosis. It is my strong opinion that these infants should have whole genomic sequence done to identify the exact mutation if the disease is Duchenne. My rationale for requiring that is that if Duchenne is suspected, that all the specific drugs approved currently by the FDA at the current time are all antisense oligonucleotides, and they require a very specific molecular diagnosis for them to be effective. And there are more antisense oligonucleotides being generated all the time, so you should know exactly what the mutation is. As a primary method for newborn screening today, whole genome sequencing doesn't meet the very high standards for sensitivity and specificities that some of the current biochemical techniques possess, largely tandem mass spectroscopy for inborn errors of metabolism. Whole genome sequencing, however, will serve as an excellent molecular confirmation of diagnosis. This will lead to an orderly and clear transformation. Since many genetic diseases don't have a functional test suitable for mass spectroscopy or such, whole genome sequencing will become more critical in newborn screening. It's clear to me that the need for genomic sequencing in the newborn period is here, and it is critical that the integration of genome sequencing into the newborn screening system be wisely and very carefully orchestrated. Thank you very much.
Would you take a question or two?
Sure.
Would
If they're not
anybody
hard.
like to ask a question or two of Dr. Howell?
Should all conditions that have genomic sequencing be done have a biomarker attached to them, such as abnormal Bell Allen or whatever, some type of biomarker to confirm that pathogenicity is present before some intervention is done with child?
Oh, I think that will be a critical issue when one switches to whole genome sequencing. In other words, when you're doing tandem mass spectroscopy and particularly knowing what we do about like phenylketonuria, and you have an elevated phenylalanine, you can predict what's going to happen. But when you have a series of mutations and so forth, and all the interactions that these mutations may have within the human, obviously that's a different issue. But that, I think, is going to be the subject of all the wise people in the room here.
Hello. Okay. Hi. So I was just wondering, when the response to the initial newborn screening that you had published, when the professor of ethics made that, claim that it was hurting children rather than helping them, what was your team's response to that? How did you, what sort of wisdom do you have for scientists who are combating, fear tactics or misinformation in that sort of realm?
I can speak personally about that because I took that with great insult, because the thing is, having spent your entire career in the area, although you don't see and treat all the patients, you are friends of the people who treat them all. And so I knew that clearly was not the case. And so what we did is that we were able to get HRSA to give a grant to a very distinguished young pediatrician who happens to have a PhD in history to review to all the published and available information about patients that had complications from the treatment with PKU. And that was a big job. And the thing is, and again, they identified a patient who had died, I might point out, who had died, that they could not 100% characterize the nature of that. But the thing is that the other complications that they could identify at that point were the ones that I mentioned, and that was that patients that we treated, we would have the weight would stop going up, and so you'd have to readjust the diet and so forth. So there were a number of complications that I would call transient complications that you manage clinically as you do as you regulate, blood sugar and diabetes or something. You basically do that. But basically, we actually published an article and so forth. But since the person who spoke what he did was not interested in facts and so forth, it had no impact. Obviously, facts were not on his mind.
I have a question, Dr. Howell. What do you think is similar and what do you think is different as we approach an era where many of us think newborn sequencing in one form or another will become a standard someday?
Yeah.
But as you think back on newborn screening and you look forward to this, what is similar and what is different, either in the science or the society that we're now facing?
Let me come briefly and make one societal comment. One of the things that we've learned in the newborn screening, and there are a number of people in the room who are world experts in newborn screening and so forth, but I'm doing the talking right now. So anyway, but the bottom line, one of the things that we've really dealt with in recent years that has been surprising to me is that a small number of people have been extremely vocal about the fact that the lab has your DNA, and babies go to baby meetings and stuff, that their T-shirts printed that says, you have my DNA and so forth. And so this has been a really big issue. And so I think that one of the things that will be very important is messaging about DNA for the public, because there are certainly vocal members of the public that are very concerned about about that particular issue. I think that there are a lot of similarities that I think about. For instance, when tandem mass spectroscopy was first introduced, obviously you get a gazillion compounds, and you have to focus on, so just like in genomic sequencing, you get a gazillion bits of data. And so that large numbers of data were common then. And I think that, and they said that's one thing. But I think that being concerned about that and so forth, I think the similarities are really very similar about bringing a new technology, et cetera. It's my impression, and again, I think that you all have obviously been talking about prices in the economy and so forth. But the thing is, I think that the economics of the sequencing, I don't think is going to be that big of an issue compared to the current way that they're not light years different than what we're looking at today.
Now, in the newborn sequencing space, no one that I'm aware of is thinking about doing this without considerable consent. Is there an alternative universe you could imagine where newborn screening got started with consent? And how would the world look different? In other words, if you act a one-on-one consent, every single mother or parent, about newborn screening as it is today, and they had the right to just say, no, thank you, how would that have been different? How would that have played out? And is there a lesson there or some sort of anticipated concern for newborn sequencing?
I think that one, getting informed consent from people is a big job. And certainly I'm looking at Don Bailey here and so forth. I know he's done a number of studies where they've gotten consent. And number one, it's very time consuming. And that would be a big problem in the system we have today, because the hospitals don't have the funding to provide people to go around and ask the question. That would be a real problem. The second thing is that if you ask a large group of people about anything, a substantial number will say no. Because if you're asking about it, it must be something bad or something wrong with it. And so you're going to get no's. And so you won't get universal. And universal, the universality of newborn screening has historically been very important. And et cetera.
In a way, PKU was sort of the stalking horse that got us in the door. Like,
yeah.
We didn't want to let people say no to PKU.
Yeah.
So there was an overriding state concern for the benefit of children that was considered, right, Don, to override the choice of parents. Yeah. And I guess one of the things we can discuss tomorrow is there even one gene or 5 genes or 20 genes that are so compelling, so unable to diagnose and treat, without that there is a similar overriding concern, and these become in some future the justification for unconsented sequencing, or for a tiered system where this becomes part of the state mandate and additional add-on sequencing, all the other things you could do with a sequence, becomes consented. And what would any form of consent? I know the newborn screening community is very concerned that newborn sequencing might disrupt, shine a spotlight, and actually disrupt the universality of newborn screening.
It would be a very big problem if all of newborn screening as we do it today had to have full consent. That would be an issue and so forth. I think that would impair the program.
So absent such a PKU for sequencing, I think we're going to have to really think hard about how this rolls out in a real sense. And again,
the individual states and individual hospitals and so forth all come up with different rules and regs about what they would require for consent. And that's one of the issues, is that there's no uniformity across the country, as far as I can see, about what sort of you need to do.
All right. Well, thank you so much again, Dr. Howell, and we really appreciate it.
Thank you.